What is the largest thing you can think of? Is it a mountain, an ocean, a planet? Let's go a little further. Zoom out. A galaxy with 100 billion stars spinning through the dark. Now go bigger again. Clusters of galaxies, superclusters, filaments stretching across space for hundreds of millions of light years. Keep going, because at the largest scales we've ever measured, the universe doesn't just get bigger, it stops making sense. Astronomers have found structures so vast, so utterly enormous, that they simply shouldn't exist. And if they're real, something about our fundamental model of the cosmos, the entire story of the universe, is wrong. For decades, we've held on to a core idea that if you zoom out far enough, the universe becomes a uniform, homogeneous place. But a series of discoveries are forcing us to question everything. What are these colossal structures, and how did they get there in a universe that's supposed to be orderly? To understand why these discoveries are so shattering, you first need to understand the rule they seem to break. It's a foundational pillar of modern cosmology called the cosmological principle. Simply put, it says that on the largest scales, the universe should look basically the same everywhere. Think of it like this. Up close, the cosmos is lumpy. You have stars, galaxies, and clusters of galaxies. But if you zoom out far enough, all that lumpiness is supposed to smooth out, like dust hanging in sunlight. The galaxies and clusters should become a random, uniform pattern. This isn't just a nice idea, it's a hard prediction. Based on the physics of the Big Bang, cosmologists calculated a theoretical size limit for how big any single, connected structure could possibly get. The current thinking puts that limit at about 1.2 billion light-years. Above that, you shouldn't find any single, organized object. Gravity, the force that builds things, just hasn't had enough time in the 13.8 billion years since the Big Bang to pull together anything bigger. For decades, this principle held up. It was the bedrock of our standard model of cosmology. But that foundation is now showing deep cracks. In 2024, a PhD student named Alexia Lopez was analyzing data, not looking for anything revolutionary. But she found something that sent shockwaves through the astronomical community. A structure now called the Big Ring. It's an almost perfect ring of galaxies and clusters with a diameter of 1.3 billion light-years. Let that sit for a moment. Its circumference is 4 billion light-years. Our own Milky Way is about 100,000 light-years across. The Big Ring is so large that if you could somehow see it in the night sky, it would take up the space of 15 full moons. Located 9.2 billion light-years away, the Big Ring blatantly violates that 1.2 billion light-year size limit. It is a colossal object that, according to our best models, simply should not be there. As Lopez herself said, "From current cosmological theories, we didn't think structures on this scale were possible." And the mystery only deepens when you learn how they even saw it. Keep watching, because there is an even bigger surprise. We are moving up gradually to the supermassive structures. Surprisingly, you don't see something like the Big Ring by pointing a telescope. It's too vast, too distant, too faint. Instead, astronomers used a painstaking method, turning the universe's brightest objects into cosmic backlights. The key is quasars. They are the intensely luminous cores of distant galaxies, powered by supermassive black holes, and they are so bright they can be seen from across the observable universe. As light from these quasars travels for billions of years to reach us, it passes through the cosmic web, the filaments of gas and galaxies stretching between voids. When that light passes through a gas cloud, certain elements absorb specific wavelengths, leaving dark lines in the quasar's light spectrum. It's like a cosmic barcode that tells you something is there. Lopez and her team analyzed the light from hundreds of quasars, meticulously mapping the shadows cast by this intervening matter. Slowly, a pattern emerged. The absorption lines weren't random. They formed a distinct, coherent shape, a near-perfect ring, 1.3 billion light-years across. It was a stunning piece of cosmic cartography, revealing an impossibly large structure that had been hiding in plain sight. As if one impossible structure wasn't enough, the Big Ring isn't an isolated case. In 2021, the same researcher, Alexia Lopez, had already found another anomaly, the Giant Arc. Spanning an even more incredible 3.3 billion light-years, it's a colossal crescent of galaxies that also shatters the cosmological size limit. And here's the most mind-bending part. The Big Ring and the Giant Arc are cosmological neighbors. They sit at the same distance in the same patch of sky, separated by only 12 degrees. The odds of two such gargantuan structures forming so close together by pure chance are almost zero. It strongly suggests they are part of an even larger, interconnected system. And they aren't the only giants. In 2025, another team announced Quipu, named after the Incan system of knotted strings. It's a filamentary structure 1.3 billion light-years long, with branching sides, containing the mass of 200 quadrillion suns. Then there's the most controversial titan of them all, the Hercules Corona Borealis Great Wall. First identified in 2013 by mapping gamma-ray bursts, the violent deaths of massive stars, this structure is estimated to be an almost unbelievable 10 billion light-years across. That doesn't just break the record, it shatters the scale. However, it's critical to note its existence is highly debated. Many scientists think the clustering of explosions might be a statistical illusion, not a real object. But with confirmed structures like the Big Ring and Giant Arc, the evidence is mounting. The universe is far lumpier than it has any right to be. So what does this all mean? If these structures are real, then the cosmological principle, that foundational rule of a smooth universe, is in serious trouble. This isn't a minor tweak. Something is deeply wrong with our understanding of how the universe is put together. The problem is twofold. First, size. Our models have no mechanism to create structures this large. The second problem is time. The universe is 13.8 billion years old. Gravity acts too slowly to have gathered this much matter into such enormous configurations. It's like finding a fully built skyscraper just hours after the foundation was laid. These structures are too big, and they formed too fast. The universe somehow built these impossible objects in its first few billion years of existence. That's not just surprising, that's a problem, a real one. A problem that current cosmological models have no clean answer for. What do you think is going on here? Is this a sign that our most fundamental theories are broken? Or are we seeing the first glimpse of a new kind of physics? Let me know your thoughts in the comments. And if you're enjoying this journey to the edges of what we know, make sure to subscribe and ring the bell so you don't miss what we uncover next. Scientists are now scrambling to make sense of these impossible structures. A few hypotheses are emerging. One idea involves something called baryon acoustic oscillations, BAOs. In the early universe, sound waves rippled through the hot, dense plasma. As the universe expanded and cooled, these sound waves froze in place, leaving behind vast, spherical shells where matter was slightly more likely to clump. The Big Ring could be a perfect cross-section of one of these ancient cosmic sound shells, aligned perfectly with our line of sight. A more exotic theory involves cosmic strings. These aren't normal strings, but hypothetical, impossibly thin defects in the fabric of space-time itself, like cracks forming in freezing ice. If they exist, their immense gravity could have acted as seeds, causing matter to accumulate around them in enormous lines or rings. And then there's the most dramatic possibility. Our standard model of cosmology is incomplete, or just wrong. This is exactly how science moves forward. When observations conflict with theory, it doesn't mean science failed. It means we're on the verge of a breakthrough. These structures are signposts, pointing toward a new, deeper understanding of the cosmos. We are at a fascinating moment. We've built a remarkably successful model of the universe, but the universe itself keeps reminding us there is more to the story. We found the Big Ring, the giant arc, Quipu, colossal structures that seem to defy our most basic rules. They are profound challenges to our understanding of everything. Are they the echoes of ancient sound waves? Are they cosmic necklaces strung on hypothetical threads of space-time? Or are they the first evidence that our entire map of the universe needs to be redrawn? We don't have the answers yet, but the search is what science is all about. These discoveries reaffirm that the cosmos is more complex, more structured, and infinitely more mysterious than we ever imagined. The map is not finished, and we are the cartographers, humbled and excited to be drawing it, one impossible discovery at a time.